Okay, let's look at example 2 from the worksheet. This is a question approximately from the book. In an attempt to increase business on Monday nights, a restaurant offers a free dessert. And there's some dessert days. Okay, the following are the number of diners on a random sample of 12 days while the offer was in effect. Okay. And then he gives us a box plot of the data, which we'll come back to. And then here at the very end, we see the question. Can you conclude the mean number of diners differs from 160? And there's our alpha. So step 1, we need to set up the hypothesis. Hypotheses. Can you conclude the mean number of diners differs from 160? This is our alternative hypothesis. We have to write it in math. This is a mean again. Differs from means not equal to 160. The opposite of this is that the mean is equal to 160. Step 2. I need to find the alpha, and there it is. Alpha is 0.01. So in this example, in this problem, he set the alpha a little bit lower. Now he's saying 1% would be unusual. So let's see what kind of test we have. This is a mean and not a proportion. And we do not have sigma, right? So it's a mean. And there's no sigma. So this is going to be a t-test. And we also need to decide, is it a right-tailed test, a left-tailed test, or a two-tailed test? Because the alternative is not equal to, right? We don't have any alligator, so we have a two-tailed test. And it looks like this. And this is a t-test again, so I'm going to have to use my, well, I could use my calculator, but we can use the book. Let's look at the table again. All right, so we go off degrees of freedom. Oh, I should write that down. Sorry. Degrees of freedom is n minus 1, and we've got a sample of 12. So degrees of freedom is 11. Okay, sorry. And if, sorry, if alpha is equal to 0.01, and I've got a two-tailed test, right, then I've got half of that in each tail. So I'm going to look up an area of 0.005 and degrees of freedom of 11. And that should be on my chart. Oh, yay. So area in the right tail is 0.005 and 11 degrees of freedom. My critical value is 3.106, says the book. 3.106 on the right-hand side, and the left-hand side is negative 3.106. So this is my likely space. Anything in between. If it falls in there, it's likely to happen. If it falls out in the tails, then it's unlikely to happen. And if it's unlikely, we're going to reject. Right? So there's the unlikely space. And those are our rejection regions. Also called critical regions. All right, step 3. For means, I need a good random sample. And I need n greater than or equal to 30, or a normal population. Okay, we do not have n greater than or equal to 30. We have 12. And this is why in part A, he gives us this little box plot. And he says, we're going to look at this and see if it looks approximately symmetric and if there are no outliers. And this is approximately symmetric and no outliers. So we're going to assume it's okay. So this question here in part A, is it reasonable to assume the conditions for performing a hypothesis test are satisfied? According to the box plot, yeah, this is okay. Do we have a good random sample? Well, the mean number, it's kind of hard to tell. It says these are the number of diners on a random sample of 12 days. I don't know. We'll I guess it's good enough. We'll go with that. I'm not entirely convinced, but the textbook author says this is great, so we're just going to keep going. All right, step 4 is where we actually put it in the calculator. So we're going to need mu sub 0. Again, that's the value in my null hypothesis, so that's 160. I need x bar. Oh, look at that. I don't have x bar. So there's a couple things to do. I can put these numbers in my calculator and compute x bar and s, or I can use input equal to data is the command on a TI. On a Casio, the data, instead of data, it says list. But we're going to do that because that's the easiest way. So, oops, let me turn my calculator back on. And let's clear out a list. Oh, except I forgot how to do that on a Casio. There we go. Okay, so I'm going to put these numbers in. 6, 69, 191, 152, 212, 139, 142, 151, 174, 220, 192, 153. Okay. So on a TI, right, you're going to do stat, edit, edit, put the numbers in the list, go back to stat and test and t-test. Right, on a Casio, I do test and t and one sample. And then here on the Casio, I'm going to hit list. Right, on the TI, you're going to put input as data, and it's going to ask you for a list number. So you want to tell it you put it in list 1. You're going to put in mu sub 0 as 160. Tell it it's in list 1. Frequency is 1. Right? That means use every number on the list once. And then you're going to have to choose your alternative hypothesis. That's at the end of the questions. On a TI, it's up here at the top on a Casio. So I put in not equal to. And then I've got everything I need. Hit execute. And there's my answer. I'm going to move this over here. Okay, so I can write down my t statistic, 1.836, and I'll write down that p-value underneath, just so we have that also. Okay, so these are my results. I also want to make sure I check the very top line on my output where it says mu is not equal to 160. And I need to make sure that that matches my alternative hypothesis. So now I'm going to make a decision. I'm going to step 5. The t value, this is a t-score, how many standard deviations I am away from the mean. I'm 1.8 standard deviations away from the mean. So I'm still in this likely space. So this result that I got, is likely to happen if the null hypothesis is true. I have no evidence against the null hypothesis. So because that t-value is in between my critical values, I don't reject the null hypothesis. And the p-value I'm going to compare to alpha. So I've got a p equal to 0.0935. This is greater than alpha, which was 0.01. And so again, I don't reject. So step 6. Because I didn't reject the null hypothesis, the null hypothesis is my conclusion. The question asks, can you conclude the mean number of diners differs from 160? No, our conclusion is that it is 160. So the mean is probably 160. Now, why didn't I say we have proved that the mean is 160? Well, because it's just probability. We haven't actually proved anything, but it's likely that the mean is 160, right? So we could also say the mean is likely to be 160. Or another way to answer that question, can you conclude the mean number of diners differs from 160, is to say we can't conclude the mean differs from 160. Step 7, we want to go back and look at step 3 and see if we have any reservations about this. Now in the book, he says everything looks good. Me personally, I'm not entirely convinced that this is symmetric. I think they really need a bigger sample size. So for me, for step 7, I kind of ran out of room. I would recommend that they do a bigger sample size. We should have a bigger sample size. Okay, let's take a break again.